All right, so now we're going to add a step 2, finding the RAA. So it says, use the RAA, related acute angle, to state an equivalent expression. So now they're going to ask you to do one more step in addition to what we were just doing on the previous example. So to state an equivalent expression. So we're still using RAA to state an equivalent expression. So we're adding one more step to it. So first thing I want to do is I always picture it. Later on, you don't have to draw it. For now, this year, we usually ask you to draw what you're thinking so that we can kind of follow along. In grade 12, some people draw it, some people draw it less because they can picture it a bit faster. For this year, I want you to draw whatever, the little quadrant and whatever you're thinking here. Okay, so we've got this. 130, you don't have to use a ruler, I'm just doing it. Okay, you do not have to use a ruler, unless you're faster with a ruler. Right, but I'm just doing it just to keep my notes neat for you guys. Okay, so then this is 130. Does that make sense? Right, so from the positive x-axis and going positive direction means up. So that's 130. So my RAA, are we getting used to it, is how much? 180 minus 130. Right, so in my head, I'm going 180 minus the 130. You don't have to show me that. Right, but to get that angle there, which would be 50. Right, so my RAA is 50. RAA is 50 degrees. Okay, so I found my RAA. I want you, so that's what we did last time. Oh, and which quadrant is it in? So I want this to become natural. Every time I do this, I always look at which quadrant. So CAST, it's the S quadrant, right? You don't have to write all the letters, just show me it's S quadrant. S quadrant, RAA is 50. That's what we did in the previous example. I want one more thing added to it now. So now, based on the fact that I showed you this thing where, look, if you did sine 20, it's the same answer for all of them. I want you to do that thing. So I know it's the same as sine of 50. So I know it's equivalent. So I'm going to say this is the same thing as me calculating sine of 50. Sine of 50 is actually the same as me doing sine of 130. Does that make sense? Because we found that those were the same answer. Right? So they're saying use this RAA to write an equivalent expression. So they're saying if I found sine of 50 and sine of 130, I'm going to get the same answer. Why is it significant that it's in the S quadrant? Why is that significant? Because it's going to be positive no matter which one. I can even prove it to you. Look. Sine of 50 is 0.76, whatever, 0.7660, whatever. Sine of 130 is exactly the same number. So those are going to be equivalent. So that's why it says an equivalent expression. So how can you write it the same way, but using the related acute angle, using our RAA? So there I did it. That's all they were asking. So they're not asking you to calculate. I don't want the decimal. They weren't asking for that. They were saying, write it again in an equivalent way. So it's like me saying, people are always like, wait, what did I do? If I said to you 2 over 6, an equivalent would be 1 over 3, right? So it's the same thing. I haven't done anything. I didn't calculate. I didn't make it a decimal. I'm just changing the form, kind of like reducing it. Does that make sense? You always feel like I didn't do anything, but that you're not doing anything, you're just reducing it. You're reducing it to a kind of a lowest form. That makes sense? A little, sort of, strange, but okay. Just go, okay, that's what you want me to do? I will do that. Okay, so that's all. You have to go, so you want me to just rewrite it kind of in a reduced way. Yes, that's all it is. Okay, but they don't never say reduced, but that's what they want. Let's do it again for cos of 120. I always find these questions hard when you're reading it. You're like, I don't know what you're asking me. That's my problem. So that's why. So kind of I'm walking you through what they're asking. So if I see this and I say CRAA, I'm going to right away draw my little quadrants. Again, you don't have to do it with the ruler. I'm doing it because I want it. I'm trying to keep my notes neat because then I scan them for you and all that stuff. So do that. 120 would be here. Hopefully you're getting faster. So it's 120. Doesn't have to be perfect. So that's 120. So my little RAA is going to be, and again, you don't have to show me this, but it's going to be 180 minus the 120, which would get me 60. So my RAA, okay, and again, you don't have to show me the subtraction, right, but my RAA is 60. Got it. Which quadrant is it in? We already know this from the previous question. It's still in the S quadrant. Okay, So I want you to simplify it. Think of it like simplifying it. So I'm simplifying the cos of 120. So I know that cos of 120 actually simplifies to be cos of 60. Right? Simplifies to be cos of 60. Same. But anytime we're doing anything on a quadrant from now until forever, that is an opportunity for you to not lose a mark. I won't say it in the opposite way, okay? Don't lose this mark. I need you to check for negative, positive. Anything on quadrants now can be negative or positive. That's the difference between everything we did last year in grade 10. We never had negatives. So here, this is cos of 60, right? So we're saying it's related acute. It's like reducing your fraction. But because it's sitting in the S quadrant, it's going to be negative. Whatever my answer is, it will be negative. So instead of getting cos 60, so look, you can even check some of these. I don't recommend you sit there checking all your answers, but just to prove to you what I'm doing, cos of 60 is 0.5, right? If I do cos of 120, it's negative 0.5. It's exactly the same answer, right? So it's like I reduced it, but I have to stick a negative in front of my answer because I'm sitting in the other quadrant. Yes?
So is it only not negative if it's correlation to like what quadrant it is?
Yes,
Like,
exactly.
If you have, like, cos 340, then you wouldn't have to change anything.
Exactly. So that's where the cast rule is. See, look, S has the quadrant sign in it, so it's positive. And here, cos is sitting in S's quadrant, so you have to stick a negative in front of it. So the letters are going to tell you where it's negative or positive. So that is where that's the whole cast rule. So anytime you're drawing anything in quadrants, you want to double check that you didn't miss a negative. We're going to do 2 more. Yeah. Okay, we're going to do 2 more, and then we're going to come back and talk about the cast rule again. So that's why it's going to wrap around to the cast rule, and you're going to go, oh, so wherever it's in its own letter, that's its own quadrant. So sine is positive in the sine quadrant, and it's also positive in the all quadrant. Cos is positive in C quadrant and also the all quadrant, because all of them are positive there. So let's try tan, right? So let's try tan. Again, I'm doing all this with rulers. You don't have to. I'm just trying to keep it neat so you can read my writing. Okay, so we've got this lovely thing here, 200. So 200 is here. Are we getting used to drawing it? Right, so we've, yep.
So how will we know which one's positive, which one is negative?
Oh, from the letters, C-A-S-T. So cos is always positive in the cos quadrant. The ratio of the adjacent to the hypotenuse will always be positive here. The other two will be negative. A, all of them are positive because all 3, right, lengths are positive. Sine is positive here, and tan is positive here. So when I ask you a question, this is telling you which quadrant it's in. I'm going to go backwards later on, and I'm going to give you the answer. I'm going to say 0.325, which quadrant is in, and you're going to have to tell me which possible it is. And it's going to have repeats, yeah. So then I'll ask it backwards, and then you'll be like, now I have to figure out which quadrants you want me to put it in. And that's when we use cast rule again. Yeah. Okay, because then it's going to go backwards and forwards and backwards and forwards. And then this comes with the idea of, okay, if I want the amplitude, or if I want the graph to be here, so then you can apply this. Trig is applied in so many ways, right? So that's why. So trig is actually very, very applicable in science classes and stuff. We just have to get the math in you right now. We're just going to get you to understand the math of it, and then the application can come later. Okay, so here, the related acutes between the terminal arm and the x-axis, yes, always between that, never between anything else. My x-axis is the important one, right? That's the one the related acute goes towards there. I'm not drawing the full right angle triangle because I don't need to right now, right? Just because we're not using the full triangle, so that's why I stopped there, just being a bit lazy. So dot there. That 200 here, so if this is 200, then this little angle here is 180, or 200 minus 180. Right, the other way, so it's going to be 200 minus the 180, which gets me 20. Is that right? So 20 beyond. So my RAA is 20. Is that all right? Right, so we're doing the same pattern. So 20. Okay, so now simplify the tan 200. Tan 200 simplifies to be tan of 20. Right, so it's like simplifying a fraction. I was thinking, so you're just like simplifying it to the lowest. It's a weird way of doing a fraction, so it's not like a fraction, but kind of that way. And then whose quadrant am I in? C-A-S-T. C-A-S-T. So without knowing the lengths of anything, I know it will be positive, so I'm going to leave it that way because I'm in the T quadrant. So if you're in the T quadrant, you leave it positive. You're sitting in your own quadrant. Making a little bit of sense? You're following the pattern, right? So at this point, you're trying to follow the pattern of what we're doing. So let's do two more. Two more. One. Okay, I left a bit more room for this one. These are my last two. Okay, so we've got this one, 330. 330 should be here. Are we getting used to which quadrant? Okay, going a bit faster. So 330 is almost the full amount around, so 330 should be over here. So that is 330. The little related acute angle is the angle between the terminal arm and the x-axis, always, 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 right? How much is that? 30, right? So RAA is 30. Whose quadrant am I in? C quadrant. And tan is going to be reduced to, so reduce tan first, reduce it to tan of 30, right? It's like reducing your fraction. It's just the weirdest fraction you've ever seen before. So reduce it to tan 30, and since it's sitting in the C quadrant, you need to stick a negative in front of your answer because your answer will be tan of 30, but with a negative in front of it. Yes? Oh, wait for, yeah, front seat. Okay, and we're going to draw it one more time. So it draws in the same quadrant, the C quadrant. So let's do here. All the way around. And this one's 340. Okay, and I know that this is my related acute angle, so my related acute angle is 20. Are we getting used to that now? Okay, so reduce your cos 30. So reduce it, please, to cos of 20. And it's sitting in its own quadrant, the C quadrant, right? So you leave it positive. Is that making sense with the C and the A? Yeah.
Do you have to draw the graph?
Yes, for now. Yeah, for now. Okay, just for this year, and then we're going to not. Yeah. Okay, just for this year, and then next year I'm like, draw it, don't draw it, doesn't matter. I just want to see that you drew it real quick. And again, you don't have to do it with a ruler, just really quick sketch right there, and then get the 220. Okay, so just really quick. I'm just doing it with the ruler, like I said, to keep my notes neat for you guys. All right, let's try it again. Determine the primary trig ratios. What am I asking for? Oh, 180 and 0. Okay, so this is two special ones. Sorry, I was trying to figure out what my question was asking. So determine the primary trig ratios. So first of all, let's highlight what it's asking. Primary trig ratios is sine, cos, and tan. So as soon as I see that, I know that I'm asked for sine, cos, tan. So in my brain, primary trig ratios are sine, cos, tan. Okay? These are special angles. How are they special? They're 180 and 0. So I can't do this. There is no related acute angle. So let me show you the first one. So all of these will be done the same way. How many did I do? Just 2? Oh, no, I did more. So I did all of them. So I did every axis. So these are all different. I left way too much room, but that way we can talk about it and you can draw a little bit bigger. Try not to draw your little grid thing too small, especially if I'm marking it so I can read it. And then also you can read it, right? So draw it big enough so you can label it. So we're going to draw this one. So these are special. So now if you go, why are they special? Watch. They're 180. So from my original arm here, right, from this arm here, I'm turning around 180. So that means I'm going here. And I'm landing on the x-axis. So that's my terminal arm. So from this around there. Huh. And you go, okay. And you say, that's a strange angle. Because what's my related acute angle? There is no related acute angle, right? How can you get that terminal arm and the x-axis? There isn't one. So this one has to be done in a different, That one has to be done in a different way, okay? This one has to be done with the formula. So what formula do I mean? I mean with the x, y, and r. So originally, when we started this whole cast rule, we have all of this. And we came up the y and r and the x and the r. This little formula here, and it's kind of just a pattern, comes from this first quadrant. So I'm going to draw that, and we're going to use y and r and x and r and y and r to solve this. We're going to do it this way for now. After chapter 6, then I can teach you another way. There's kind of 2 ways to do this. So in grade 12, I come back and I'm like, okay, so there's 2 ways I showed you. I actually like the chapter 6 way better. I find it easier, but we haven't learned it yet. So when you come back, you'll be like, oh, that's actually better. Okay, so we'll readdress this question again at the end of chapter 6. But for now, we have only 1 way to answer it, not 2 ways. It's not a bad way. Chapter 6 is just a faster way. It's even faster. You'll be like, oh my gosh, that's even less thought process. So in chapter 5, they want you to do it only 1 way, which is using the coordinate. So if I was to draw this coordinate and say this was my terminal arm and I stopped here, what coordinate could I give that? If I was to label that as a coordinate, what coordinate could I give that? -1, 0. Does that make sense? And when I choose something other than -1, not really. Like, why choose -17? It's all going to reduce anyway. -1. So that's why we started on the unit circle. We said 1 is a nice radius. -1 over 0. -1 and 0. Right? The x value is -1, the y is 0. We're okay? How about here? What if I wanted it on 0? What if I wanted it on 0, the terminal arm? Oh, you don't have to put an arrow. Sorry, I'm going to use to grade 9. You can just do terminal arm. Sorry, I was doing grade 9 earlier, so I'm putting an arrow on. Okay, so my terminal arm is here. Terminal arm is here. Put a dot. Okay, how would I label this coordinate? 1 along the x, 0. Does that make sense how I'm labeling it? Okay, so label the point at the end of my terminal arm. Does that make sense? We'll do the 3 other ones. I'll do the other arms on the next page. Good? Okay. Then I want you to go to the formula. I hate memorizing these formulas. So what I do is I draw the first quadrant. So I do this. Right angle. This is x. How do I know that's x? Because it's along the horizontal. This is y because it's up and down, and this is r, and that's my reference angle. So what do I want? I draw this. You don't have to draw this if you don't want to. So these guys you would draw to show me you know where the terminal arm is. This is my brain thinking formula. I don't like memorizing. So on the other side, sine theta is y over r. Cos theta, it's y over r. Cos theta is x over r. Does that make sense? And tan theta is y over x. Some people memorize this. They memorize this part. Right? I'm just not good at memorizing. I always picture it. I actually picture my triangle, and y I know is up and down because it's up, right? And x is across. So I picture that instead of memorizing this. Some people memorize this. Some people picture this. It's up to you. I want you to use this. You have to use this to answer your special angles. What do I mean by special angle again? 180, 0. Where are my other special angles? Where's another one going to be? 360 and 270 and 90. Okay, so when you get those special angles, I need you to go to this formula. And you're going to answer it this way. So then you're going to go, it says all of them. So sine of 180 equals, I want cos of 180 equals, and I want tan of 180 equals. So it's testing, do you understand the word saying primary trig ratios? It wants you to do this for 180. So it actually wants all 3 of those. So sine of 180, and I got my coordinate. From my coordinate, you might be like, where am I supposed to use this? This is my x and y for my formula. What is r? What is r? If I chose that as 1, r is 1, always. Okay, if I chose that as 1, is 1. If I chose that as 2, r would be 2. But why choose 2? You're going to have to reduce your fraction anyway. Okay, so sine of 180 is y over r. Y is 0. And what did I say R was? 1. So how much is that? 0. Okay. Cos of 180 is x over r. And you can even write x over r if you want. Do you want me to write that as a formula? Do you want me to write x over r and then fill it in? Yeah, I could do that. Right, so here I could have added y over r. And then x over r is, x is -1, r is 1, so my answer is -1. Okay, try it again. Tan of 180 is y over x. Sorry, I got squishy there. I'm going to rewrite this. Tan of 180 is, this is why I left so much room, so you can do your formula. So it'll be y opposite over adjacent, y over x. Y is 0. What's x? -1. That gets me 0. Okay, try it again. Again, this is only for the special angles, right? So the special angles are hitting on the axes. All right, so we're going to do sine of 0. Sine of 0 equals y over r. So I'm going to write the formula. Y over r. How do I get the y and the r? One more time. This is x. This is y. What's r? R is 1. So y would be 0. R is 1. What's 0 divided by 1? 0. And again, all of these lovely patterns come into the graphing, which you get to in chapter 6. We learn how to graph it. Okay, so sine of 0. How about cos of 0? Cos of 0 is, what's the formula? X over r. X is 1 over 1, so it's 1. Last one. Tan. Okay, tan of 0 equals what? What's my formula? Y over x, right? And that's why some people memorize it. They're like, oh, you know what? I've done it so many times I memorize it. If you ever forget, though, draw the diagram. Okay? Y is 0. X is 1. So tan is 0. Good? Did I make any mistakes? 1, -1. Okay. Any questions with that? Mm-hmm. Yes, whatever the value is. So if that's a 2, you would make R2, but everyone chooses 1, yeah. Because then otherwise, look, I get 2 over 2. So for this one, you get 2 over 2, so it's 1. So everyone's like, just choose 1 then. Yeah, yeah, see? Yeah, yeah. Okay, yep. Sorry, sine and tan. Sine and tan are 0? For this one. For 0. Yeah, for 0, sine is 0, tan is 0, cos is 1. For this one, sine is 0, cos is -1, right, how it's not the same, and tan is 0. Then we're going to do more. Let's see the other axes, right? And then we're going to see. It's not something, this is not something easily memorized until I show you what the graph looks like. In chapter 6, I'll show you the graph, then you can actually memorize it faster. Memorizing random zeros and ones, it's too much in your brain. So they always say, go to the chart. Go to this, yeah, do the formula. But then after in chapter 6, I show you the graph, you can memorize them. Because you'll be like, oh, I can plot it, it's so fast. But without the graph, it's hard to memorize. So they want you to do this whole formula thing. It's how they get the graph. But then once you get the graph, you can go backwards and forwards so fast, yeah. So eventually you'll be able to go 0, 1, 0, 1, yeah, like that fast. Okay, so for now, it flips a bit. So let's try again. Let's try 2 more. I'm going to